All right, looking at some more delta phasor diagrams. So in this circuit, we're going to complete a phasor diagram for a balanced delta connected load with a unity power factor. So when it says unity power factor, that tells me that these are all resistors and they're all the same value resistors. Now the rules for delta. So number one rule for delta is that V line and V phase are the same thing. There's only one. So if I have a line voltage of 240 volts, that's exactly what each one of the resistors will see in the phase. It's the same thing. So V line equals I phase or V phase. So because this is a resistor, whatever phase current can go through, it's going to be right in phase with V phase. So I phase in phase with V phase. And we know that the line current here, when we're dealing with a balanced circuit, balanced delta, it's going to be I phase times √3. So it's going to be a factor of 1.732 larger than the individual phase currents. And because it's balanced, I line will always lag I phase by 30 degrees. So that was established when we added up those individual phasors, IA to B plus IA to C. Mm-hmm. So this is for balanced only. Okay, so I'm going to put my one and only voltage for delta here. That's my VAB, which is the V phase and the V line. It's the same thing. And then let's put our phase current on. So volt drop will be across the resistor, and the current that's allowed to go through the resistor is going to be right in phase with the voltage across it. So I'm going to put it right there. There's my phase current, I phase. Now the line current, we know it's going to be 1.732 larger than the phase current, but it's also going to lag by 30 degrees. So we have to plot that right at 330. There you go. There's your I line. And so we have a 30-degree difference between the phase current and the line current right there. In this case, phase current or line current does lag our line voltage or phase voltage by 30, but the relationship is to the phase current because that may change. So I think we're ready to roll on this. So I phase blanks V phase by, so there's your I phase, there's your V phase. Well, that's kind of a trick question. It's in phase. We've got unity power factor, so 0. Next thing we got here is V line to V phase. Well, that's another trick question. It's the same thing. In phase, so 0 degrees. Next thing we got here is I line blanks V line. All right, well, that one, I line is there, V line is up here. So I line in this case would lag V line by 30. Next one is pretty much, pretty much the same question as top one here. So V line, well, that's the same as V phase. Blanks I phase, well, in phase, it's the same. Zero degrees. The next one, V phase to I line. Okay, well, that would be leading because we're starting it with V phase, starting the sentence with V phase. Leading by 30. That one good?
Mm-hmm.
Okay, let's move on to something with some power factors here. 0.866, so lag, that is 30-degree lag, right?
Yep.
Okay, so go ahead and put our line and phase voltage on, which is the same thing. There's your V line or V phase, same thing. So looking at that volt drop, our phase voltage here, VA to N, and then the current that's allowed to go through there due to the impedance of that coil and that VAB, I should say, VA to B phase voltage, it's going to end up 30 degrees behind that voltage. So let's plot that IAB back 30. So there's your IAB, which is your I phase, right?
Mm-hmm.
Okay. And then we know that the line current, so I line is equal to I phase times √3, but I line also lags I phase by 30, and this is for balanced only. Balanced circuit, we're good to go. So back 30 for the line, and it's going to be a larger vector because it's 1.732 times larger. So that's your IA. So that's your I line. All right, just going to put some values in here. Phase current lagged phase voltage by 30, and then I line lagged I phase by 30. All right, I think we're ready to do some answers here. So start in the sense with I phase. So right here, blank's V phase.
Legs by 30.
Awesome. Legs by 30. Start in the sentence with V line, so that's here. And comparing it to V phase. Well, trick question. In phase, same thing. 0 degrees. Okay. Next one, start in the sentence with I line down here. And comparing it to V line up here. So it would, starting from here, it's behind V line or it lags. And by what?
60.
60. Awesome. Next one, V line. So up here would be blank I phase. By how many degrees? It would, because we started the sentence with V line, that means we have to state it as leading
By 30.
By 30. Yep. And then the next one, V phase, all the way to I line. Well, because we're starting the sentence with V phase, we have to say it's V phase is leading I line by 60, right? Oops.
Mm-hmm.
Yeah. Fun, eh? Good times. Not too bad though, as long as you work through it systematically. I always just deal with line A and AB because that's just what I'm used to. It's on the 0. All the rest of them are going to look the same, right? So if you put VAB there, sorry, VBC, we would see that IBC at 30 degrees back. So I'd put it at what, 210. And then we'd see line current would be another 30 degrees back. So it'd be at IB would end up at 180, right? So everything would just shift.
Mm-hmm.
So you can deal with any other phase you want and do it with any other phase if you like, but I find it just easy to go from the 0, whatever's on the 0. So
Yeah, it just
The
makes
rest
it
all,
make sense.
yeah, the rest all just follow suit, right? So, okay, we're going to a lead. So once again, we got to put like a little capacitor in this. There, it's an RL circuit now, or RLC in the phase. I'm gonna switch up some ink here. Actually, let's switch it up here. So 0.766 lead is that's 40 degree.
Yeah, 40 degree.
Yeah. Okay, so we got 40 degree lead. Okay, so that we talk about that way. It's always referring to the current leads voltage, right? So or current lags voltage, but in this case, current leads voltage. When you see these statements, is what that means. So you've got 480 phase voltage and line voltage. So that 480 volts right here, that's your V phase. The current that is allowed to go through the phase is going to lead that V phase by 40 degrees. So plus 40. All right, so that'd be your IAB. So there's your one and only voltage for delta, your VAB, which is your V line or V phase. Now I got to put that current, the phase current on, which is going to be leading by 40. Oops, that's a little long. There we go. So there's your IAB, and it's up 40 degrees. And this is your I phase. So the rule for balanced was I line equals I phase times √3, but the other big one here, I line lags I phase by 30. And as long as it's balanced, that statement is always true. So where do I put my line current? At what degree mark here?
10 degrees.
10, yep. So I go back 30 from my phase current. Oh, I tried. That's my straight line. So there's my I line, or IA. So I got 10 degree displacement here, 30 up above. All right, I think we're ready to answer a couple questions. So you got I phase, blanks, V phase. So I phase, starting the sentence there. All right, well that's leading, right? By 40. Next one is V line. So this will be a lag because it's the bottommost one. V line lags. Where are we going to? I line. So that's here. Lags by
10.
10. Yeah. V line lags I line by 10. Next one is I line. So we're starting the sentence here. Yeah, okay, just going below. So it's the same thing, just asked reverse, right? The start of the sentence is I line, so it leads by V line by 10 degrees, right?
Mm-hmm.
Okay, next one is V line right there. And it's going to I phase, which is up here. So that'd be a lag, right? By the full 40. Last one, V phase. So that's this to I line. Okay. All right. Well, that's lags by
10.
10. Yep. Awesome. And that's lag. So once again, so you have your 480 V phase. So VAB is 480, sorry. And whatever current is allowed to go through there due to its impedance, well, it's also going to be delayed and 10 degrees lag from that voltage. So putting our one and only voltage on, VAB, And we got to draw that current back 10 degrees, right? So it's right there. Let me try that again. That's better. That's 10 degrees, pretty small there. I phase, which is your IAB. And then where do we put line current from here? If it's balanced, we can just go back 30 degrees, right? 10, 20, 30, yep, so about 320. That makes sense. So 30 degrees here, and that's your IA, line current IA. So I line. Perfect. All right, now now that I got the phasor diagram done, I'm going to attempt to answer this. I phase, there we go, versus V phase. So just like I would normally interpret it when we read it like the sentence up above, I phase would lag V phase by 10 degrees. Yep. Next one, I line, starting there. So that's down at the bottom. I know it's going to lag, and this is that always rule actually. It lags by I phase by 30 degrees, always for balanced. Next, I line, so down here again, versus V line. So up here, what would it be lagging by? What's the total 40. There? 40. Okay. 30 plus 10. Yep. Next one, B line, right there, versus I phase. Well, we can say it's actually the line voltage is leading phase by 10, phase current. And B phase, so back to where we were starting here, to I line. It would be leading by the full 40, right? There we go.